the integral of x squared over the square root 1 minus x squared dx. What technique would you use there? Trig sub. The dead giveaway is the square root there. A lot of times if you have square roots, not always, but usually you can do a trig sub, okay? So, my trig sub, does anyone know what the substitution is? Sine. X equals sine theta, okay? So use trig sub for this one. Okay, let's do, maybe how much more time we got? Yeah, we'll do like maybe 3 or 4 more. The integral of sine to the 5th cosine to the 4th t dt. What kind of integral do I have here? It has trig functions in it, right? What trig functions do I have? Sine and cosine, yes. So, you pull off a sine, right? You use your rules. We know how to integrate sines and cosines. We have rules that tell us what to do, right? So I'm really happy if I see something like this because I know just follow my rules and I'm okay. So you break off the sine, put it at the end, right? And then what would I do?
Turn the sine to cosine.
Yeah, so rewrite this as sine squared, squared. And then we rewrite the sines into cosines. How do I do that? What equation? Yeah, 1 minus cosine. 1 minus cosine squared. Sine t dt. And then, how do we proceed? U sub. My U is what? Cosine. And then minus sine t dt. So make sure you pull that minus out in front. You can integrate from here. Okay? All right. Let's say we want to do the integral. We want to do the integral x secant x tangent x. Yeah, you can do an integration by parts. How did you know to do that? Yeah, you knew the integral of part of the, you knew how to integrate part of the integral, right? You knew how to integrate secant times tangent to get secant. So you're going to break it up into a u and a dv, and you're going to put secant tangent with dv, because you told me you know how to integrate it. You get secant. So then everything else has to go in the x position, so that's this, or in the u position, so that's x. And it's been a little while since we've done integration by parts, so we'll go ahead and finish this problem. Remember, you've made this table, you go across and then diagonally down. So when I'm doing this, I'm getting x secant x minus the integral of secant.
Isn't the natural log of secant tangent?
Secant plus tangent, yes. So that one's an integral we should know. I gave you the formula before. It's ln secant plus tangent plus c. Okay?
Where did the secant x come from this?
Where did this one in the integral come from?
Yeah.
So in the table, we integrate secant x, tangent x, so I need some function whose derivative is secant times tangent, and that happens to be secant. Yeah. And then whatever goes in the integral comes from going diagonally down the table. Other questions? Okay. So in that, we'll do 2 more, and then we'll be done, okay? Let's say I want to integrate arctangent of the square root of x. Okay. We start asking, can we simplify anything? And the answer is no, because it's really just one term. You have arctangent of square root of x, so you can't separate those two. Square root of x, it gets inputted into the arctangent function. So they're stuck together and they can't separate. Okay? If I wanted to do a substitution, right? What would I want to pick for you? Square root of x. Its derivative is 1/2 over, and then a square root of x in the denominator. I don't have anything else in my integral, right? I don't have its derivative there. So that's not really going to work. Remember that this is really just one term here, right? And we did some integrals where we had only one thing, one term in our integral, like when we integrated ln of x. Do you remember how we did that?
Tangent times 1, the thing we did up there a second ago. I'm forgetting.
Ooh.
Like, yeah.
We did, what was an earlier technique we learned way long ago? I've done it. What did we do on the last example? We just did integration by parts, right?
Well, we could derivative of arctangents for this.
Yeah, add in a 1, just like you told me. Okay, so let's do that. Arctan square root of x times 1. And then I need to pick my u and my dv. And remember, whenever you're using this trick where you put in this 1, u has to be whatever was in the integral. So it has to be this arctangent of square root of x. The arctangent cannot go in the dv spot, because if it went there, you would already know how to integrate it, right? So you'd be wasting your time doing integration by parts, because you would already know how to do it. So it has to go in the u spot. Okay. So we integrate 1 to get x. Derivative of arctan of square root of x.
Square root of x over x plus 1.
Hold on. What's the derivative of arctangent of x?
1 over square root of x.
1 over 1 plus x squared, right? So 1 over 1 plus the square root of x squared. And then you have to multiply by the derivative of square root of x. 1 over 2 divided by the square root of x. Yeah. Okay. And then you follow your table. And hopefully you can integrate. I'm not going to keep going. Huh?
Can you pull it up?
Yes. Yes, I can. Sorry about that. Yeah.
Arctangent is 1 plus.
1
It's just x squared. For arctangent.
Uh-huh. The derivative is 1 over 1 plus x squared. Right?
Yeah, square root.
Yeah, because I have to use the chain rule when I'm taking that derivative. Which is why I spent all that time on the very first day of class reviewing chain rules.
That's why you multiply it by the derivative.
Well, but you have to plug in.
Okay,
Yeah. So be very careful with your derivatives. All right, I want to do one more real fast before we're out of time. Okay, so let's do the integral ln of x over x square root 1 plus ln of x squared dx. Any ideas? Can't really, yeah, u sub, you said it. What would my u be? ln of x du is 1 over x dx, which I happen to have in my integral. I have an x in the denominator. So that means I'm perfect. I'm ready to go and do u substitution here. Oops, sorry. So you're gonna get u over the square root 1 plus u squared du. What are you gonna do from here?
X equals U equals tangent.
Yeah, you're gonna do another trig sub, right? Trig sub. You're gonna do u equals, we said tangent, theta, okay? Again, the dead giveaway is I have a square root, 1 plus u squared, so that tells me I should be able to do a trig sub, okay? So practice, 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 I think is how you get good with this stuff.